Good morning, students. In the previous video I told you about permutations and combinations. Here we can discuss the difference. What is the difference between permutations and combination? As we know that permutation is a kind of actually arrangement when we arrange the objects in a different order. Combination is a kind of selection. So in case of permutation, the different ways of arranging set of objects into a sequential order, that means order is required. Where in case of combination, one of the several ways of selecting items from a large set of objects without considering an order is termed as a combination. Order is very relevant. It means order is required in case of permutation, where order is not required in case of combination. We can say order is quite irrelevant. Permutation denotes the arrangement of objects, where combination is a kind of selection. It does not denote the arrangement of objects. In case of permutation, multiple permutations can be derived from a single combination, where from a single permutations only a single combinations can be derived. Permutation denoted by NPR, which is equal to n factorial upon n minus r factorial. Children, again factorial means the mathematical operations which represent the multiplication of the all numbers between 1 and n. Combination denoted by NCR, n the total number of object, which is equal to n factorial upon r factorial multiply n minus r factorial. So all this is about the combinations and permutations and difference. In the previous video I told you about permutations and combination. Permutation is a kind of arrangement, where combination is a kind of selection. Combination is represented by NCR. N is the total number of objects, R the favorable number of cases, and the value of R could be greater or equal to 0. Let X be the n event, then it is greater or equal to 0 or less than equal to R. It means R value can be equal to 0 or greater than it, and R value could be equal to 1 or total number of objects. So it is represented by NCR, which is equal to n factorial upon n minus r factorial into r factorial. Factorial term, that is also I explained in the previous video. Again you listen it carefully. Factorial is a mathematical operation which represents the multiplication of the number between 1 and n. For example, you are finding the value of 5 factorial that is equal to 5 into 4 into 3 into 2 into 1. In support of that, taking question, how many chords we can draw on through the 21 points on a circle. So n is equal to 21, r we have taken there 2, so that is 21c2, which is equal to 210. 21 factorial upon 19 factorial into 2 factorial, that is equal to 210. Question number 2, how many ways we can select 3 boys and 3 girls from a group of 5 boys and 4 girls? So we can select 3 boys from 5 and 3 girls out of 4. So 5 factorial upon 3 factorial into 2 factorial multiply 4 factorial upon 3 factorial multiply 1 factorial, which is equal to 40. So this is the answer of this question. Another question, select 9 balls from 6 red, 5 white and 5 blue balls. It means the total number of balls are 6 and 5 11 and 5 16. We have to select 9 balls, 3 from each. So number of combination is equal to 5c3 multiply 5c3 multiply 5c3, because from each color we have to select 3 balls. So that is equal to 6 factorial upon 3 factorial multiply 3 factorial multiply 5 factorial upon 3 factorial multiply 2 factorial multiply 5 factorial upon 3 factorial multiply 2 factorial, that is equal to 2000. Another question, how many 3-digit even number can be made using the digit 1, 2, 3, 4, 6, 7 if digit is repeated, if no digit is repeated? So total number of digits are 1, 2, 3, 4, 5 and 6 and 7, sorry. And 3-digit even number we have to draw. 3-digit even number, it means in unit place we are supposed to getting unit even number, that is 2, 4 and 6. There are the three even number, 2, 4 and 6. It means unit place we can fill in three ways, that you can write 3C1. And total number of digits are there 1, 2, 3, 4 and 5 digits. So unit place can be filled in the three ways, and digit we can take either 2, 4 or 6. Since given that the digit cannot be repeated, so unit place is already occupied, the 110th place can be occupying by the remaining 5 digits. So that we can, one digit already we have filled, and total number of digits are there 1, 2, 3, 4, 5 and 6. So 5P2, because one digit we have already filled in the unit place, remaining digits are there 5, so 5P2, which is equal to 20. So total number of multiplications theories, and number of 3-digit number is equal to 3 multiplied 20, which is equal to 60. Next question, how many words with or without meaning can be formed using all the letters of the word equation? EQUATION. So how many digits is there? 1, 2, 3, 4, 5, 6, 7, 8. 8, there are the total number of letters 8, and we have to select all, so you will write it as 8P8, which is equal to 8 factorial, and 8 factorial means 8 multiply 7 multiply 6 multiply 5 multiply 4 multiply 3 multiply 2, that is equal to 40320. Question number next, how many words with or without meaning can be formed using the letters of the word Monday? How many letters there in Monday? 1, 2, 3, 4, 5, 6. 4 letter taking at a time. So how you will represent it? 4 letter taking at a time means the favorable cases are there 4, and total number of outcomes is there now 6. So you will write it as 6P4, that is 6 factorial upon 6 minus 4, that is equal to 2 factorial, is equal to 360. Second part, all letters are used at a time. All letters are used at a time. The total number of letters is 6, and you are using the 6 letters at a time, so that is 6P6, which is equal to 720. Next question, how many of the distinct permutations of the letter in the Mississippi do the 4 I's not come together? Children, first of all, in every questions of permutation and combination, you check how many letters used. In the word Mississippi, total number of letters is there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total number of letters is 11. I appearing 4 times, S appears 4 times, and P appears 2 times, and M appears 1 time in the given word. So number of permutations of the word Mississippi is equal to 11 factorial upon the product of the words repeated. That is 4. I appear 4 times, so write 4 factorial multiply 4 factorial multiply 2 factorial is equal to 11 multiply 10 multiply 9 multiply 8 multiply 7 multiply 6 divided by 4 multiply 3 multiply 2 multiply 2. So these 8 objects in which 4s and 2 p's are arranged. See, this is what actually, if all i's write one time, all i's you write at a time, then total number of letter will be 8 factorial, because total number of letter actually 11 there. We have 4 i's is there, we just make one packet of i's, so 11 minus 4 is equal to 7, and that become 1 i, so total number of letter will be 8 factorial 8, so 8 factorial upon 4 multiply 2 factorial, this is equal to 840. So therefore the number of permutations where i's do not come together, see, when i's come together, that is equal to 34650, and when i's do not come together, that is equal to 840. So write total number of letters when i's do not come together is 34650 minus 840 is equal to 33810.